open that recording. Okay, perfect. All right. So this meeting is now being recorded. That's for anyone who couldn't make it or anyone who wants to just go back and review. All right, let's get back into it. Okay, now we also have fractions. Fractions basically have a numerator and denominator. Sometimes you can simplify fractions to be integers, sometimes you can't. So fractions are things like 1/2, 5/7, 3/4, 8/16. Those are all fractions. Now I'm going to scoot this over a little bit and introduce some pretty interesting numbers. We've got rational numbers. So rational numbers include integers, but they also include fractions. So anything that can be expressed as a fraction is a rational number. So for example, I can actually express 1 as a fraction 1/1. I can express 2 as a fraction 2/1. And so you can see how integers can also be expressed as a fraction. So fractions and integers make up rational numbers. So now you might be asking, is there something that's not rational? And we call that irrational. So I'll actually go ahead and write this in red just for a little bit of contrast. We have irrational numbers. And basically, these are things like square roots and things. Pi is irrational. If you guys have ever heard of the letter E, that's also irrational. These are all examples of irrational numbers because they cannot be expressed.
Wait, excuse me?
As a fraction.
Would pi be
So there's
irrational
actually
number?
lots of proofs out there about why pi cannot be expressed as a fraction or why the square root of 3 cannot be expressed as a fraction. It's a little tricky on the math side, but if you guys are interested, you can definitely look those up. Okay, awesome. And then finally, we have the real numbers. And the real numbers are literally just all numbers. Every single number. Irrational, rational, integers, natural numbers, whole numbers, all of those are made up in the real numbers. So this is just everything. And most questions will ask you like, if you've ever encountered like on a math like sprint or something, they talk about real numbers. That's basically just to indicate that you can have rational solutions, you can have fractional solutions, and so on.
Okay.
Awesome. I see, Adek, you have a question. Do you want to go ahead and unmute and ask it?
So then does that mean irrational numbers and rational wait, does that mean that rational numbers are just numbers that can be expressed as a fraction? So if something is not rational, that means it cannot be expressed as a fraction, like how like all integers and like all whole numbers can be expressed as a fraction. So would that be irrational?
That is absolutely correct, yes. So rational numbers include whole numbers, natural numbers, integers, because all of those can be expressed as a fraction. So that is absolutely correct. I did see one comment in the chat. Anviti asks, are rational numbers negative? Rational numbers can be negative because remember, negative numbers can also be expressed as a fraction. So, okay, Ruchi, do you have a question?
My name's actually Shreyansh.
Okay, awesome.
And, my question is, can pi be expressed as 21/7?
So 21, okay, actually, that's
I mean 22/7, sorry.
Yeah.
Wait, I thought pi was expressed 3.14 and more.
So that's a really great question. Great comments, you guys. Pi, so 22/7 is actually not pi exactly. It's an approximation. So pi 22/7 is not the exact value of pi. Like Muktika said when she unmuted, pi is like 3.1415 and 27 and so on and on. So because there's so many like digits, it's impossible to express as one single fraction. So pi is irrational. Okay, awesome. Now there is one more group beyond real numbers. Those are the complex numbers. So the complex numbers are made up of real and imaginary parts. And this one doesn't pop up as much in number sense, but I just want you guys to be aware because they do pop up in math. So complex numbers, you can't see them. They're imaginary. They're made up of imaginary parts. And this is a little bit more of an advanced topic, but basically, you're unable to, when you're taking like square roots and stuff, you get an imaginary part when you take the square root of a negative number. So if that sounds like super crazy to you, don't worry about it, because it is pretty crazy and the math can get pretty complex with that. But I just want you guys to be aware that there is something beyond the real numbers. Okay, awesome. Just one quick thing, please don't unmute unless you're called upon, because we don't want that extra like background noise and stuff. So yeah, just make sure your mics are muted unless like you're specifically called upon. Okay, awesome. So I want to give you guys just a couple of diagrams to maybe help you, those visual learners out there, to help you guys see what these numbers look like on the number line and things. So let's go ahead and get some of those visuals. I'm going to go ahead and clear up the screen. Awesome. Okay, so for a whole number, I'm going to go ahead and show you guys what whole numbers on the number line look like. So whole numbers start at 0 and go all the way onwards from there. So we're literally just starting from 0 and then counting forever upwards. They don't include negative numbers, fractions, or decimals. On the number line, it's literally just 0, 1, 2, 3, 4, all the way up until infinity. Now, in contrast, we've got integers. Now, integers are a little like whole numbers, but they're a little different. And this is what integers look like. So integers include positive integers, which remember is another way to say whole numbers. But they also include negative numbers. So that includes things like -1, -2, -3, and so on. So whole numbers greater than 0 are called positive integers, and then numbers less than 0 are called negative integers. Something that includes positive integers and 0 is called non-negative integers. So I'll go ahead and write that over here. This group is non-negative integers. So that just means you're not including negative numbers. If you guys do have questions while I'm lecturing, you're also welcome to like direct message me through Zoom, because I'll still see those messages. So you don't have to raise your hand all the time and like wait for like 5 minutes. You can always just direct message me. Okay, awesome. Okay, one thing to note is that the integer 0 is neither positive nor negative. It's literally just 0. So that's why when we say non-negative, we include both 0 and positive numbers. Okay, Naranjana asks, do mixed numbers count as rational? Yes, because mixed numbers are a sum of integers and rational parts, you can express it as a fraction. So yeah, it is a rational number. Okay, awesome. Okay, cool. All right, so let's talk a little bit about comparing numbers on the number line. I think number lines can be very helpful if you're trying to compare small numbers. So we're going to go ahead and kind of visualize. Actually, hold on. I don't want to minimize the whole. I want to minimize this one only because the integers are going to be a little more helpful to us. Sharanya asks, do negative fractions count as irrational or rational? Negative fractions are rational because you're still able to express them in fractional form. Awesome. Okay, so integers on the number line increase from left to right, and then they decrease from right to left. So in this case, we're increasing in, whoop, sorry about that. In this case, we're increasing in this direction, and then we're decreasing in this direction. So that means the value of an integer is less than an integer to its right on the number line. So that means, for example, if I go to 2, 2 is greater than 1, so that means we're increasing in this direction. On the other hand, if I go negative, -2 is greater than -3, so we're decreasing in the other direction. So positive numbers are always greater than negative numbers because they're further on the right of the number line. And when you're using a number line to compare, numbers increase as you move to the right. So whichever number is further on the right of the number line is the larger number. So let's talk about how we can denote comparisons. So we have things called comparison signals, symbols. So this symbol over here denotes less than, or actually, hold on. I'll go ahead and show you guys a little nicely drawn chart that probably looks a little neater than my handwriting. Okay, these are our symbols. A way I like to remember this is that you can think of like the comparison signs as like an alligator's mouth, and the alligator always likes to eat the larger number. So the sign is always opening up towards whichever number is larger. So for example, if I was comparing -4 and 5, which number would be larger?
5.
5, yeah. Remember, you guys can always put your answers in chat as well. You don't have to unmute. You can put answers in chat, and I will definitely see that. So yeah, 5. Great job. All right, what about -5 and -2? Which number is greater? -2. Yeah, thanks. Okay, wow, the chat is super awesome. You guys are doing really great. So yeah, -2 is greater. You might think like, oh, that's weird. 2 is a smaller number, but remember, 2 is farther on the right than -5, and so that's why it's greater. So the alligator sign is pointing towards the -2. Okay, that's a little bit of comparison between numbers. So we're just gonna do a little exercise that puts all these topics together. Okay, let me go ahead and share with you guys the problem. Okay. All right, arrange the following integers in order from least to greatest. So if you want to just go ahead and put your answers in the chat, you are welcome to do that. And then I guess whoever I see, okay, hold on, I actually do see a question. How do we show negative numbers to fractions? So when you're expressing a fraction as a negative number, all you have to do is put the negative sign in front of the fraction. So -1/2 is expressed like that. Awesome. Great. I see so many answers in chat. This is great. I'll give you guys another like maybe 10 seconds to think through this for whoever is still working. Awesome. Okay. So many answers in chat. One thing to remember, or actually, I guess I'll go over this at the end. I will talk about this part at the end. Okay. I think I saw, hold on. Actually, does anyone want to answer this question? You guys can raise your hand and I'll call on you. Okay. Matika seems very, very excited, so I'll give her that chance to speak. Do you want to go ahead and unmute?
Hi.
Hi.
Okay, what's the question?
Oh, here's the problem. Just give me your solution to the problem.
From least to greatest, honestly, -15, -13, -7, -4, -1, negative, I mean, not negative anymore, 0, and then 2.
Good. I think there was a -7 in there. But we can
Okay, then I'll keep. I did say it was before the -4. I did say it.
Oh, okay, okay. I must have just misheard it. One thing you'll notice is that you guys are much faster talkers than I am writers. So I'm always behind you guys when you guys are giving solutions. I try my best to catch up, but sometimes I make
Oh,
mistakes.
no, it's my fault, I guess. I was
No
talking.
worries. No worries at all. Okay, awesome. So I totally agree with this solution. The reason why, so this is an absolutely correct ordering. I did see a couple of people do it in reverse. Just make sure that you're always reading the question. In this case, we're asked to go from least to greatest. So we start with -15, not 2. Okay, so once again, since we're ordering from least to greatest, we want to start with the negative numbers. And the negative number that has like the largest value associated with it is the smallest one. So that's a little backwards if you think about it, but that's their smallest number. So -15 is the farthest from 0. It's the farthest to the right of the number line. So that's what we're going to be, that's what's going to be our least number. And then we just work our way up. We get to the positives with 0. And then our next positive integer is 2. And that is the greatest in the set of numbers. So for those of you who are a little bit visual, I'll go ahead and show a diagram that illustrates like what this looks like on a number line. Okay, so this is our number line. As you can see, -15 is the farthest to the right. And then now next we have -13, then -7, then -4, then -1, and then 0, and then finally 2. So hopefully that helps you guys visualize a little bit what the number line looks like. Okay, awesome. Let me just make sure there are no other questions. Yeah, okay, awesome. Seems like most of you guys have got the hang of this, so that is great. Awesome. And don't worry if you guys raised your hand before and you didn't get a chance to speak. I try my best to call on everyone, so for those of you who are really, really eager to speak, you'll definitely have that opportunity, hopefully. Okay. All right. Let's look at our next question. Yeah, we can do another. I see a couple of you guys asking if we can do another problem, so we'll do one more before we move on to a new topic. All right. How many negative integers are greater than -8? Go ahead, take like maybe 15 seconds to think about this, and then we'll go ahead and share. Okay, awesome. I already see a lot of answers pouring into chat. I did see Vaivahi's hand go up first, so go ahead and unmute Vaivahi.
So when we're finding negative integers greater than -8, that would be finding basically any number. If we were thinking of 8, -8 as a positive integer, we just think of how many whole numbers are less than it. So it would be -1 through -7. So there would be 7 negative integers.
Good. That was a really great explanation, and I absolutely agree. So thank you so much for unmuting and sharing that with us. Once again, if you guys want to see like a diagram of that, here is a number line for you. So the main idea here is that you're only counting from -7 to -1 because all of those numbers are the only ones that are greater. Remember, -9 is not greater because it's farther to the left of the number line. So that's why we don't count it. Okay, awesome. All right. If I don't see any other questions, so let's go ahead and move on. Yeah. Please try not to spam the chat. The more spam there is, the more likely I am that I'm just going to close the chat. Okay, awesome. I see Neil's hand is raised. Neil, go ahead. What's your question? Oh, no question. Okay, that's totally fine. Awesome sauce. I'm just gonna go ahead and lower your hand so that way I don't get confused. Okay, awesome. So let's talk a little bit about some properties with these numbers. All right, so we're gonna introduce the idea of additive inverses. So an additive inverse is basically the number that when you add it to your original number, you get 0. So the sum of any integer and its additive inverse is always equal to 0. So for example, if I had the number 9, what is the additive inverse? You guys can put this answer in chat. Good. I see a lot of people saying -9, and that's absolutely correct because 9 plus -9 is equal to 0. All right, now if I have -6, what is the additive inverse? 6. Perfect. Yeah. Because if I do -6 plus 6, I have 0. So as you can see, additive inverses are very easy. You just multiply your existing number by -1. So nothing too complicated. Sometimes this does pop up, so it's important to be familiar with the terminology. Okay. Now here's a little trick question for you guys, just to see if you really understand what additive inverses are. What is the only real number which is equal to its own additive inverse? 0. Good. That's awesome. Yeah, because 0 is equal to -0 because 0 has no sign. So that's absolutely correct. Thank you guys so much for putting that in chat. So appreciated. Okay, awesome. Let's take a look at a couple of more additive inverse questions, and then we'll go on and do some more general questions. All right. So here are 2 questions. Go ahead and put your answers to each in the chat. I chose these 2 because the previous ones we did with integers, and I know a couple of you guys want to work a little bit more on fractions and decimals and things, so here's a question about that. Okay, Sid asks, how do you do a negative number squared? So a negative number squared is actually just the same as the positive number squared. So when I do -9 squared, let me go ahead and write this separately. When I do -9 squared, this is actually just equal to 9 squared because the negative squared becomes a positive. So -1 squared is just +1. So the negative and positive number squared are exactly the same. Okay, awesome sauce. Okay, perfect. I don't see any questions in chat, so this looks good, and I see lots of right answers. Okay, I see Abhinav's hand is raised. Abhinav, do you have a solution?
Well, I have a question.
Question, go ahead. Yeah.
So if it wasn't in parentheses, don't you do 9 squared and then multiply by -1?
That is absolutely correct. Good catch. So the reason why I put parentheses, for those of you who didn't catch Abhinav's comment, is to show that I'm squaring the negative value as well. If instead I had done negative and then 9 squared, that would only be negative 81 because the negative number is not squared. So really great catch up and out. That is absolutely correct. Good job. Awesome. For those of you with your hands currently raised, please lower them if you only have a solution. If you have an actual question, though, keep them raised. Okay, awesome. Shreyans, what's your question?
What if you had like negative outside the parentheses and then negative inside the parentheses, and you had to
Good
square?
question. Okay, really awesome questions about these signs and things. All right, so if I had a negative like this would actually just be negative. Remember, negative 9 whole squared is 81. So this will just be this squared. So your final answer is negative 81. If that negative sign is included in the square, it becomes positive. We don't care about it. But if that negative sign is outside of the square, then it does matter at the end. Awesome. Okay, Shiranya, do you have a question?
So, I have a question about the problem that we had just had to solve.
Yeah.
So, if it's 2.5, do we make it a mixed fraction and do minus 2/5 by 10, or would it just be minus 2 by 5?
Well,
Or
actually, you don't
2.5?
even have to make it into a fraction. You can just leave it, you can leave your answer in decimal form. So yeah, you can keep your answer in decimal form. And then all you have to do is just throw that negative sign on front. So like a lot of people in chat said, all we have to do for the additive inverse of 2.5 is just put a negative in front of the 2.5. So you don't have to convert to mixed numbers or fraction at all. That actually might be an extra step because this is the same thing. Okay, awesome. All right. Okay, I do have a question. How do you find the additive inverse of a decimal? Yeah. So this question over here explains that an additive inverse of a decimal is the exact same as the additive inverse of an integer. Because all you're doing is you're just finding that you're just adding a negative, you're just multiplying your number by a negative sign. So if I had negative 3/4, I would just multiply by -1. And so my final answer would be 3/4, like a lot of you guys said in chat. So awesome. Great job. All right, let's go on to a couple of more questions. Okay, I see Navia, you have your hand raised. Go ahead. What's your question?
Can I use the restroom?
Oh, absolutely. You don't have to ask me to do that. Okay, awesome. All right, additive inverse of an irrational number. Yeah, so the additive inverse of an irrational number is the exact same as integers, decimals, rational numbers. You just multiply your number by -1. So that's the really nice thing about additive inverse. They're very applicable to anything. All right. For our next question, we're going to be still in the realm of negative numbers. So how many negative integers are between -10 and -17? Okay, awesome. I already see a lot of answers coming in through chat. So I'm going to go ahead and start calling on people. I think, Sharanya, you had your hand raised first. So go ahead and unmute. Oh, I don't think you're unmuted. Hold on. Let me ask you to unmute. There you go.
Is the answer 7?
Is the answer 7? Tell me how you got to 7 first.
Because minus 10 is less than minus 17. But so if you subtract 17 by 10, you can get 7.
Okay, so from what I'm hearing, you did -10 minus -17, and then you got to 7. Okay, cool, cool, cool. All right, do you guys agree or disagree with this answer? Okay, I see a couple of people saying agree. I see a couple of other people saying disagree. I think we're actually pretty split here. This is interesting. Okay, awesome. And I see so many hands raised. Kashvi has been very desperately asking to answer this question, so I will give her that opportunity. Go ahead, Kashvi, and share your answer.
So first I thought it was 8 because in counting I learned that you have to do 17 minus 10, 7 plus 1, 8. But when I noticed when I read the question again, it said between. So that means we're not gonna count 10 and 17, which takes away 2 from 8, and that equals 6.
Good. Okay. Cool. So what do you guys think about the answer of 6? Do we agree with that or do we disagree? Agree. Okay, a lot of people agree. I still do see a couple of disagrees. All right, I'm going to resolve this once and for all and literally just count the numbers, and then we'll go over which explanation is correct. So like Kashvi said, a key point in this problem is that we're talking about between -10 and -17. So that's absolutely correct. We don't include the boundaries if we're talking about between. We are only including the numbers that are strictly less than and greater than our boundaries. So that means we'll include numbers like -16, -15, -14, -13, -12, and -11. We don't include -17 and we don't include -10 because these numbers are our boundaries. So in total, that gives us 6 negative integers. So yeah, if instead we had just asked how many numbers there are from -10 to -17, the right answer would be 8. But in this case, because we are asked for between, we want to find the boundaries, we want to find the total number of numbers, and then subtract 2. So that way we're not counting the boundaries. I think I've had 51. I know that's not your name, but I really like the word you used there. Yes, the numbers are exclusive. We're not counting -10 and -17. They are excluded. So that's absolutely the right way to describe this. Okay, awesome. Perfect. I'm just going to go ahead really quick and lower all hands just because I see a lot of raised hands, just in case someone has questions. Okay, for those of you who didn't know like why we're subtracting these numbers in the first place, to find the number of integers between bounds, what we're going to do is we're going to subtract our bounds and then add 1. The reason why is we want to try to get our numbers as close to 1 as possible because it's easy to count how many numbers there are from 1 to 20. There's 20. Everyone knows that. It's easy to count how many numbers there are from 1 to 10. There's 10. So we want to try to get our bounds to start with 1. And the easiest way to do that is to add 18 to both numbers. So if I do -17 plus 18, I get 1. And if I do -10 plus 18, I get 8. So from 1 to 8, there are 8 numbers. But remember, I don't include my boundaries, which is why I subtract 2 to get a total of 6 numbers. Okay, awesome. Muktika, do you have a question or do you have a solution?
I want to say something really.
Okay, if possible, could you put that comment in the chat? I only want to like take care of questions on the unmute.
Okay.
Okay, awesome. Thank you so much. All right, Tanvi, did you have a question?
Wait, I actually have a question. What's
Yeah.
the next question we're doing about? Like, what's the topic?
Sorry, say that again?
Like, what's the next question we're gonna do? Like,
I
what?
don't know. You'll have to see. You will have to wait and see.
Oh, okay.
Okay, awesome. Tanvi, do you have a question?
How did you get 1 for -17 plus 18?
Good. So when we're adding negative numbers, we can kind of think of it as like subtraction. So if I do -17 plus 18, actually, if you want, I can draw a little number line over here. So this is my 0, and this is my number line. This is -17 over here. So from -17 to 0, we have to add 17 because remember, that's what our additive inverse does. It gets to 0. The additive inverse of -17 is 17. And then I go one further to get to 1 because it's really easy to count numbers from 1, starting from 1. So then in total, I have 18 total numbers. So I have to add 18 to -17 to get 1. So hopefully that clears that up a little bit. Okay, Sharani, do you have a question?
Yeah, so is exclusive like including and then no, not including the numbers, and inclusive is like including the numbers?
That is absolutely correct. Great definition. Yeah. So exclusive doesn't include the boundaries and inclusive does include the boundaries. Yeah, that's the main difference. All right, awesome. Let's go ahead and move on. If you guys do have additional questions, go ahead and put them in chat and I will take a look. All right. Now, here's a good question for you guys. This one is a little bit of counting, but it's just good general knowledge to know. If you are not actually sure about this, don't worry. We'll go ahead and prove today why it's right. This question. Okay, awesome. I see a lot of people putting 90. I see 99s, 100. Okay, lots of different numbers here. All right, I did see Udvik's hand go up first. So Udvik, do you want to go ahead and unmute and share?
I think it's 99 because like if you count from 1 to 99, then 99 it's two-digit numbers, so that's why.
Okay, awesome. I think your audio was a little like scratchy for me, but from what I heard, I think that was really great. So let's go ahead and talk about that. All right, so with two-digit numbers, remember we have 2 digits, and I like to denote digits with dashes. So for our first digit in a 2-digit number, how many possibilities do we have? How many possible digits are there for the first number, for the first digit, the tens digit? 9, good. So we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, but we cannot have 0. 0 is not an appropriate starting digit for a two-digit number. So there are 9 possibilities. What about for the second digit? 10, good. Now for the last digit, yes, we can have 0. So you can include all 10 digits. So then if we, for each possible tens digit, there are 10 possible units digits. So for 9 total tens digits, there are each 10 possible units digits. So in total, there are 9 times 10 equals 90 two-digit numbers, and that is our final answer. Okay, awesome. All right, for the next part, this is just a follow-up question. Try to use the same techniques to see if you can answer this next part. Remember, unless you have a question, don't raise your hand just yet. We'll try to keep the comments and stuff to the chat. So unless you have a question, go ahead and lower your hands. All right, thanks. Perfect. So I see a lot of people saying 900, and that is absolutely correct. Remember, we have 3 digits. So the first digit has 9 possibilities, the next has 10, and the last one has 10 as well. So if we go ahead and multiply these together, we get 900 total 3-digit numbers. Okay, awesome. All right. I do see a lot of questions, and I don't have time, unfortunately, to answer all of them. So if you guys want to put that in chat, I'll try to answer them throughout the class, but I don't know if I cannot let you guys unmute and then like have you guys share all the time. So yeah, if you guys do have questions, leave those in the chat for the time being. Okay, awesome. Let's go ahead and move on. So we're going to talk a little bit about Roman numerals. How many of you guys have heard of Roman numerals?
I have.
Yeah? Okay, awesome.
Me too.
Oh, that's so cool. Okay, great, great, great. We don't use Roman numerals that much, but they do pop up, so I definitely want you guys to be acquainted with the system. I'm going to go ahead and paste a chart that shows Roman numerals to Arabic numeral conversions. Remember, the Arabic system is what we use. So there you go. As you can see, they use letters to denote their numbers, so that can get a little bit confusing, but don't worry, we'll definitely explain like where these come from. All right, so 1, the I is represented by an I. That's pretty easy to remember. V is a 5. X is 10, L is 50, C is 100, and you don't really go past that, but if you want to remember D and M, you're totally welcome to. Okay, so typically we write Roman when we're converting an Arabic number to a Roman numeral, we try to put the symbols in decreasing order. So we start with the largest symbol first and then work our way down. But if you ever see a Roman numeral followed by a symbol that is equal to or less than of it, you add its value together. So, for example, if I had xi, what would my value be? 11, perfect. Now, what about if I had XVI? I.
15.
Careful. Yeah, 17. So we have 10 plus 5 plus 2, and that's going to be 17. Good. So I can only put digits, Roman numerals in a decreasing order. So for example, I couldn't do something like X, or actually, yeah, hold on. That is not the right comment at this moment. Okay, I do need to include one more step. Good, 17. All right, awesome. So if a Roman symbol is instead followed by a number that is greater than it, you should subtract the value of the large one minus the smaller one. So instead of instead of xi, I had done ix, what number do I get?
9.
9, good, yeah. For easy questions like this, you guys don't have to unmute. You can leave your answers in the chat. So good, 9. All right, what if instead I had done XL? What do you guys get? Put your answer in the chat. 40, awesome sauce, yeah. So we do 50, which is L, minus X, that's 10. So 50 minus 10 is 40. Now, I couldn't do something like VL because V and L are not next to each other. So if you look at this chart, V is too far from L, so I can't do V right before L. If, let's say I wanted to express the number 45, for example, instead of VL, how could I express 45? XLV, yeah. I think of you could put that in chat. So yeah, we would do XLV. So we would do X and L, that comes out to be 40, and then that V gives us that extra 5. So 40 plus 5 is 45, and that's where that comes from. Okay, awesome. All right. All right, so we'll do a little bit of conversions. Just 2 more examples, and then we'll go ahead and move on. So go ahead and convert 20 to Roman numerals, and then go ahead and convert, let's see, we'll do that for fun. And then just put in chat what you get, and we can check together if that is correct. Good. So I see a lot of people saying 20 is XX, and that is absolutely correct. We just have 2 x's together. So 10 plus 10 is going to be equal to 20. Good job. Awesome. And then what about that second one? All right. I see a lot of people saying 76, and that is absolutely correct. So this first term, we get 50 minus 100. So that's 50 plus 20 plus 10 plus 10, and then plus 5 plus 1. Remember, because the 1 comes after the 5, we add, not subtract. So in total, we get 76. Perfect. And that's our final answer. All right, so that's the bit on Roman numerals. Let's go ahead. I just want to interject a fun little problem here. This is just kind of, I hope, a brain break, but it'll still be important for the rest of our class. So let's go ahead and talk about this next problem. All right, so determine all positive integers that are equal to 4 times the sum of their digits. All right, I do see a lot of spam in the chat, so if that doesn't get cut out, I am gonna go ahead and cut the chat out, so that way everyone can like stay focused and things. So yeah, just please avoid the spamming, please. All right, let's take a look at this next question. So the way we're gonna approach this is, the most important step is understanding how to write a positive 2-digit number. So a 2-digit number can be expressed by the digits A, B. And so if I wanted to break this down into place values, how could I do that? How could I write a 2-digit number in terms of its place values? Think about what like places there are. So I have A in the tens place and I have B in the ones place. Yeah, thanks Vaibehi and also Anviti. Yeah, we can write this as 10A plus B. Since A is in the tens place, we multiply it by 10, and since B is in the ones place, we just multiply it by 1. So 10A plus B is how we express a 2-digit number. So we know that this number, 10A plus B, is equal to 4 times the sum of its digits, which is A plus B. So if we expand the A plus B, I'll go ahead and go to this term and then this term. I have 10A plus B is equal to 4 times A, which is 4A, plus 4 times B, which is 4B. Now, I know solving the systems of equations may be a little bit advanced for some of you guys. We'll go into a different class why this works the way it does, but I think it's just an interesting brain teaser for those of you who are interested. So next, what I'm going to do is I'm going to subtract 4A from both sides and B from both sides. So this keeps my equation balanced and equal. So 10A minus 4A is 6A. B minus B is just 0. And that's going to be equal to 4A minus 4A, which is 0. And then 4B minus B, which is 3B. So if I simplify, I get that 2A is equal to B. All right, so can you guys think of some possible values of A and B that would make this number work? Yeah, of youth puts 12. That is absolutely correct. In this case, B is 2 and A is 1. I also saw that a couple people put 24, 36, and 48, and these are all of our correct answers. These are the only numbers where this property applies. Any other ones are too big or don't meet the numbers. Okay, awesome. Parth, do you have a question?
Yeah, does it matter? Like, could it be any multiple of 12 or doesn't matter which multiple of 12?
So if we look at the number 60, the sum of the digits is 6, and if we do 6 times 4, that is 24. So as you can see, those numbers don't match. So it's not all multiples of 12. It's just a coincidence that it's for these 4 multiples of 12. Any others don't work. Yeah, good question.
I have a question. How do we know that we have to find 2-digit number only and not a 3-digit or 4-digit?
Yeah, okay, let's go ahead and take a look at that. All right, so if we had instead a 3-digit number, we would have, or actually, hold on. I actually think this problem has been miswritten. This is a typo. It should say 2-digit. Sorry about that. Yeah,
No problem.
okay.
Thank you.
No problem, no problem. All right, Shreyans, what's your question?
How is 10A plus B equal to 4A plus 4B?
Yeah, so what we did was we took, remember that the question is asking us for a 2-digit number equal to 4 times the sum of the digits. So this left side represents the 2-digit number, and then 4 times the sum of the digits is represented by A plus B times 4. And then we just went ahead and expanded, and that's how we got that equation. Does that make sense?
Oh, okay. Yeah.
Okay, awesome. All right, let's go ahead and move on, you guys. All right. So now we're going to talk a little bit about divisibility rules. This is super duper important in competition math, comes up all the time, so I would highly recommend you guys understand it. First, let's just start with the number 2. What is the divisibility rule for the number 2? Go ahead and put your answers in the chat. These are going to be like quick questions, so I don't want to have like people unmuting every like 5 seconds. Yeah, so it must be even. So anything that is even is divisible by 2. So must be even. So is 124 divisible by 2? Yeah, 124 is divisible by 2 because the last digit 4 is divisible by 2, so it's even. What about 127? No, good. It's not divisible by 2 because 127 is odd, since that last digit is odd. Good. So most of you are definitely familiar with what the divisibility rule for 2 is, so not too worried about that. What about for 3? Does anyone know what the divisibility rule for 3 is? So it's not actually just that the number is odd. For example, if I had like the number 7, 7 is not divisible by 3, but it is odd. So that is not actually correct. I do see a lot of people in chat already saying this. Absolutely. So if the sum of the digits is divisible by 3, then your number is divisible by 3. So sum of digits is divisible by 3. So, for example, is 123 divisible by 3?
Wait, do you say the divisibility rule of 7 here?
We are not going to talk about that today because it's a little complex. But yeah, we might cover it if we have time.
Okay.
Yeah. Okay. All right. What about, so yes, 123 is divisible by 3 because we have 1 plus 2 plus 3 is 6, and that's divisible by 3. What about 245? 245. Is that divisible by 3? No, good, because the sum of the digits is going to be 11, and we know 11 is not divisible by 3. Good. All right, now what about for 4? What is the divisibility rule? I think I saw someone put this in chat beforehand. Good, the last 2 digits are multiple of 4. That is absolutely correct. So last 2 digits divisible by 4. So is 1724 divisible by 4? Yes, yes, it is divisible by 4 because the last two digits are 24, and that is divisible by 4. All right, what about 1213? Well, 1213. Is that divisible by 4? No, good, because 13, the last two digits, are not divisible by 4. So that's how we can tell for 4. All right, what about for 5? What is the divisibility rule for 5? Yeah, the last digit should be either 0 or 5. So that one's pretty easy. So is 235 divisible by 5? Good. Yeah, it is because the last digit is 5, so we know it's divisible by 5. What about 216? Is that divisible by 5? No. Yeah, because that last digit is not a 0 or a 5. Awesome. So that one's not too hard to remember. All right, what about 6? Good, Zombie. It has to be both divisible by both 2 and 3. That is absolutely correct. So even and divisible by 3. And this is because 2 and 3 are the prime factors of 6. So if a number is divisible by 6, it must be divisible by 2 and 3. So is 114 divisible by 6? Yes, it is, because 114 is even, and the sum of its digits is 6, and that's divisible by 3. Good. What about 206? Is 206 divisible by 3? No, that's correct. Even though it is even, the sum of the digits is 8, and that is not divisible by 3. So 206 is not divisible by 3. All right, and here we get to 7. So 7 is pretty tricky. All right, so the rule is complicated. I won't write it down, but I will put you guys a screenshot. Okay, awesome. Okay, so for 7, what we want to do is we want to double the last digit, subtract it from the number made by the other digits, and if this result is divisible by 7, then our final answer is divisible by 7. So try this with 672. Is 672 divisible by 7? Okay, I do see people saying that the number has to be prime in order to be divisible by 7. Remember that prime numbers have only two factors, the number itself and then 1. So if a number is divisible by 7, it cannot be prime. So prime numbers are not divisible by 7. Okay, I see a lot of people saying yes, and that is absolutely correct. So I double the last digit 2, that gives me 4. And I subtract 4 from 67. So 67 minus 4 is 63, and that is divisible by 7. Okay, awesome. Let's go ahead and talk about 8. What is the divisibility rule for 8? Yeah, the last 3 digits are divisible by 8. So just like how 4 is the last 2 digits are divisible by 4, and how 2 is the last digit is divisible by 2, 8 is the last 3 digits are divisible by 8. So that is absolutely correct. Okay, and then what about 9? Does anyone know the rule for 9? The sum of the digits is divisible by 9. So just like how 3 is the sum of the digits is divisible by 3, for 9, the sum of the digits is divisible by 9. Okay, awesome. So is 261 divisible by 9? Yes, good. Because 2 plus 6 plus 1 is 9, and 9 is divisible by 9. Awesome. All right, what about 9821? Is that divisible by 9? 9821. That's our number. No, that's correct.
it's not divisible.
Because we have 9 plus 8 plus 2 plus 1, and that's 20. And 20 is not divisible by 9. So that's why this number is not divisible by 9. Okay, awesome. All right, let's go ahead and move on. All right, and then you guys know that for a number to be divisible by 10, it must end with a 0. So that one's pretty easy. All right, we're gonna go ahead and end this class with what I think is probably the most important thing that you guys are probably gonna see in number sense. You're gonna see this trick a lot. It's called FOIL, and it's something that we use to multiply numbers. So, all right, let's take a look. I want to show you guys this diagram to introduce this concept first, and then we'll go ahead and talk about the applications of it. So, FOIL stands for first, outer, inner, and then last. So if we take a look at this diagram, it's used for multiplying two-digit numbers, binomial, things like that. So take a look at this diagram. And if you see, first what we're doing is we're taking that first term and we're multiplying it by the first term of the next one. So we're multiplying both of the first terms together. Then we're multiplying both of the inner terms together. That's B and C. Then we're multiplying both of the last terms together. So that's B and D, and then we're multiplying the outer terms together. So every term gets multiplied by every other term. So let me clear off my arrows so that you're able to see the original diagram. I want to work through one question. So if I have x plus 3 times x plus 5, I'm going to first multiply the first terms. So x times x is going to be x squared. So in case some of you guys haven't done algebra, that's totally okay. No worries at all. Actually, to make this applicable to everyone, instead of x's, I will do like an actual number. So let's do the number 7. 7 plus 3 times 7 plus 5, and then we'll do FOIL with this. So what is 7 times 7? 49, good. All right, and then I'm going to change colors. All right, now I'm going to do the outer terms, or actually I'll do the inner terms. What is 3 times 7?
21.
21, excellent. And then I'll do my outer terms in green. So what is 7 times 5?
35.
35.
35, good. Oh, well, I didn't want to write that there. 7 times 5, and then I'm going to do 3 times 5, which is going to be
15.
15, good. 3 times 5, awesome. So I'm going to go ahead and add all of those up. I get 49 plus 21 plus 15
Algebra.
plus 35. And when I do that, I get 70 plus 50, which is, hold on.
85.
120.
Yeah, good. And so if you actually added those numbers, you see 7 plus 3 is 10, and 7 plus 5 is 12. So 10 times 12 is 120, and that's a check that we actually did this right. So this is how FOIL works. It is a little bit of arithmetic at the beginning, but if you do enough problems, you're so fast at it that it's really easy to multiply numbers.
Isn't this like transposing method or something?
I have actually never heard it called like that. I just like to remember it as FOIL. Some people call it
Oh, that's the way I learned it somewhere.
Okay, yeah, that's cool. Okay, awesome, awesome. All right, let's take a look at some examples and then we'll go ahead and move on. All right, so let's go ahead and try this example. I'll go ahead and I'll leave the FOIL diagram on the board, but I'll go ahead and erase the one that we did. So. All right, so what is 25 times 28? Don't use a calculator. And if you know any tricks for multiplying like 25s or 28s.
I know a trick for multiplying 25s.
Oh, cool. Okay, you can use it to check your work, but make sure to try this problem with FOIL because I want you guys to get used to that. All right. Okay, I see a lot of answers in chat, which is perfect. All right, I'm gonna go ahead and lower everyone's hands, and then those of you guys that want to unmute and share, or actually, hold on, we can probably do this one together. Sorry, I know a lot of you guys just raised your hands. I'm sorry. Since we're running a little low on time, we'll go ahead and do this one together. All right, so to multiply 25 times 28, we're gonna first start with the outer loop. All right, so what is 2 times, or we're going to start with the first term. So what is 2 times 2? 4, good. Yeah, awesome sauce. All right, and then we're going to go with the outer term, or the inner terms. So what is 5 times 2?
10.
10.
10, good. All right, and then we're going to do the outer terms. So what is 2 times 8?
16.
16, good. And then what is the last terms multiplied? So 5 times 8.
40.
40, good. Okay, actually, hold on. There is one small issue. Instead of, hold on, I actually messed this up, you guys. we should be breaking this number into 20 plus 5 times 20 plus 8. Because remember, that's how we break apart the place value. So if we go ahead and fix our numbers, you guys did all the right multiplications. We just missed a couple of zeros. So let's go ahead and adjust that. Let's go ahead and do 20 times 20, and that is going to be what?
400.
Good. And then we're going to do 5 times 20, which is
100.
100. Good. And then we're going to do 20 times 8, which is
160.
160.
160. Awesome. And then what about that last two terms multiplied together?
One more.
140.
Nope, just 40. Just 40. 5 times 8 is 40. Good. So now we have the right answer. So if we do 400 plus 100 plus 160 plus 40, we get the correct answer of 700, which a lot of you guys put in chat. So really great job there. All right. Yeah, one thing to be really careful with, and I messed this up when I was writing, so if that confused you, don't worry. We'll do another question to clarify. One important thing to note when you're doing FOIL is to break apart by place value. So instead of just doing 2 plus 5, you should do 20 plus 5, because that's actually equal to 25. So let's go ahead, do one more example, and then we'll go ahead and end class for today.
Now, is this FOIL method applicable only to 2-digit numbers?
No, so you can do FOIL on 3-digit numbers, and that will be on the homework, so you guys will have an opportunity to try that out. But yeah, it works on 3-digit numbers. It's just a little more complicated.
What about 4-digit numbers?
You can do that too, but I honestly would not recommend that.
Okay. It would be a lot.
Yeah, it would be a lot. It would be a lot. All right. Here is our last problem for today. Go ahead and save your questions, comments for the end of class. Let's go ahead and end with this problem, and then we'll go ahead and awesome. Wow, some of you guys are getting this really fast. That's awesome. Okay, good. All right, so let's break this up. We're gonna first start with, we're gonna break this up the right way. So I'm gonna do the right first step. We're gonna do 40 plus 2 times 40 plus 4.
48.
Good. So if we do the FOIL method, we're gonna start with 40 times 40. What is that?
1,600.
Good. All right, and then if I do the next part, that's gonna be 40 times
1,084.
Yeah. If you guys could stay muted unless like I ask you guys a question, that would be great. I just don't want a lot of background noise coming through. So next we're gonna do 40 times 4. And that's
160.
gonna be 160. Awesome. And then we're gonna do 2 times 40, which is gonna be 80.
88.
And then we're finally gonna end with 2 times 4. So let me end with like a purple. 2 times 4, which is just 8. Good. All right, so we've got 1,600 plus 160 plus 80 plus 8. And so when we add that together, we get 1848, just like a lot of you guys said. Awesome. Good. All right. So hopefully that cleared it up. I know we did a little bit of a wrong example initially, but hopefully that explanation, that solution explains to you guys why FOIL works, how it works. And this is really good for a lot of different multiplication tricks. So hopefully that's useful to you guys. All right, awesome. So this is where we're going to end for today. If you guys do have any other questions, I'm available for 5 minutes, but I can't really stay for long. So anything super specific, don't try to keep that.
Bye.
Yeah, thank you so much for coming. Really great first class. I hope to see you guys all.
Thank you.
Thank you so much.
Bye.
Thank you.
Bye.
Bye, everyone.
Bye. Good
Bye.
night. Bye.
Bye, everyone. Bye.
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 Different way.
Bye, Krish.
Bye.
Bye, everyone.
Bye.
Bye, Shri.
Bye.
Oh my gosh, you guys are having like a bye back. Awesome.
Okay,
I have a question.
Yeah, who unmuted and said they had a question?
Abisha.
Okay, awesome. Go ahead. What's your question?
How does the 2a and the equal to b become into 12, 24, 36, and 48?
Oh, okay. So we're gonna go back to that question. All right. Let me go ahead. Oh, whoops. Let's go ahead and minimize this. All right. And then I'm gonna go ahead and bring this back out. All right. Okay, so let's say I selected B as 1. So if B is equal to 1, then A is equal to twice of 1, so 2. Remember that, or actually, hold on. Let's say I selected A is equal to 1, then since B is equal to 2A, that means B is equal to 2. Similarly, if A is equal to 2, then B is equal to 2 times 2, which is 4. So that's how we're able to say the first digit is 1, the second digit is 2. The first digit is 2, the second digit is 4. If the first digit was 3, the second digit would be 6. If the first digit was 4, the second digit would be 8. If the first digit was 5, the second digit would be 10, but 10 is not a digit. So that's why we stop from that point onwards. Okay. Does that make sense? Okay, awesome.
I have a question.
Yeah, sure, Ange, go ahead.
So, instead of foil, I use loaf,
Yeah,
Loif.
yeah.
So, is that like the same thing?
It's the exact same thing. I just think foil is easier to say. It's the exact same method. The letters all stand for the same thing. I just think that foil is easier to say. But yeah, that's the
Okay.
same.
Bye.
All right, awesome. Bye.
Bye.
Bye, Arian. Okay, Vivon, I see you have your hand raised. Any questions?
Yes.
Yeah.
So for the problem where we were finding out how many positive 2-digit numbers there were,
Yeah.
I don't understand why it wasn't 89 because 10 to 100 is 90 digits.
Mm-hmm.
I mean 90 numbers. But 100 is a 3-digit number. So we have to take away 1.
Yeah.
Which
So the issue with this approach is that there are actually not 90 numbers from 10 to 100. Remember, when we're trying to find the number of numbers, we want to try to get our numbers to 1. So if I subtract 9 from both of these, I'm basically counting the number of numbers from 1 to 91. And there's 91 numbers. So like you said, we subtract 1 for 100. So 91 minus 1 is equal to 90. And this is actually the correct answer. So if I'm trying to find the number of numbers from 10 to 100, I have to do 100 minus 10 plus 1. So it's not 90 numbers, but 91 numbers in that range. Does that make sense?
Yeah.
Okay, awesome. All right. Bhumika, do you have a question?
Quick question. You know in the start when
Bye.
Times 1, like, what, negative 2.5
Mm-hmm.
divided by, would 2.5 divided by 1 whole equal negative 2.5?
So because we're finding additive inverse, we don't do any division. We just have to find the number that adds to 0. So we don't ever do 1 over 2.5 for additive inverse. We just try to see like what number do I have to add to 2.5 to get to 0. And in that case, it would be negative 2.5.
Okay, thank you.
Yeah, no problem. All right, Samanvi?
So for the divisibility rule of 7, will it work for any like number of digits?
Yes, it works for any number of digits. And if need be, if you apply the rule and you get like another big number, you can apply this divisibility by 7 rule on that again.
Okay, thank you.
Of course.
Bye.
Bye-bye. Thanks for coming. All right, awesome. I'm going to go ahead and end the meeting, y'all. Thank you again so much for coming. And if you guys need any help with any of the warm-ups, do let me know through email. All right, thanks everyone. Bye. Have a good night.